In this presentation, we're going to explore modular design, which is a better way to organize our code. Modular design splits a program into multiple components which we can develop separately. So we can write these components separate from each other, and then every module consists of a series of related operations that do one task. After we write all these separate operations, we can then combine them to create a single logical program or logical function that the overall program will perform. Now, functions are how C implements modularity, and printf is a really good example of a function. It performs one operation, it prints something. It's separate from the rest of the code. You don't even see it. You just call it. And it's highly reusable because you want to print all over your code. So it's a very common function to want to perform. Now, when we invoke it, we simply call printf here. It transfers control to the printf function. It does its printing, and then it returns, and it starts to execute the immediate line after it. So this is how functions work. We write them somewhere as a separate unit. When we want them, we invoke them. It transfers control to that code inside the function, executes it, comes back, and continues to execute the function that called it. Now, here's the idea of we've got a big project. We break it up into different components or aspects. We develop every one of those separately, and then we combine them to make an entire final programming solution. So when you're trying to design your modules, you want your module to be easy to upgrade, which means that you should be able to change how it works internally without having to change the information that is passed to it or the information it returns. That is fixed because if you make any changes there, all the code that calls it has to be updated. You don't want to do that, but as long as you can just change the internals, nobody will ever know that you made any change, and that's one of the big principles we want. A module should have a readable amount of code. It should be easily readable in, usually they say, one screen. If it's bigger than that, it's probably doing too much, and it gets harder to work with in an editor. And the other principle is that modules should be reusable. They should be usable in multiple places so that the effort you put into building one can be reused again and again and will pay off. So there are two more principles we have for designing modules. One is cohesion, and cohesion says that all of the code inside a module should have a really good reason for being there. The main reason is because all of the code inside a module is devoted to performing one task, and there's no other code that does something else. Coupling is a little harder to understand, and it refers to the number of interconnections between various modules. And interconnections you can think of as accessing a variable somewhere else or passing information between them. So the only way you should be able to pass information in is via the parameter list of the function and the return value. Any other connection is a hidden connection, and it's very hard for people to find. And because it's hard to find, they don't know it's there, and this can result in bugs in the code. And our general principle is that you want to minimize the information exchanged with other modules. You don't send a module any information it doesn't need, and it doesn't return any more information than it absolutely has to. So, as I said, functions are the way that they implement modularity in C, and here's an example of what a function looks like. Int add1, and this is a little function called add1, and that's the name of it. It's going to return an int after it does a calculation, and its parameter list is in parentheses here, and it's one integer value, which is called n. I'm going to say n plus equals 1 and add 1 onto it, and then I'm going to return the value n. Inside these curly brackets, I've got the body of the function, which is executed statement by statement, one after another from top to bottom, just like normal code. And when it says return, that's the value that it's going to return as its return type is int. So whatever we return there as n has to be an int. And then the code that called it is going to get that value back. So there you have it, some of the basic principles involved in modularity.